Alrighty, so a little bit about me. My name is Josh Long. I'm a Spring developer advocate on the Spring team at Pivotal. I'm a Java champion. That's a privilege of mine. It means that thanks to my interaction and my privileged position as being somebody who gets to talk to people like yourselves, I have benefited from a large, wonderful community, and so that's an honor. I'm also an open source engineer and contributor. I am the leading contributor of bugs to projects like Spring Boot, Spring Cloud, Spring Integration, Vaadin, Activity, etc., etc., etc. And the internet. I'm on Twitter, so I'm going to go ahead and I'm hoping that in 2016, everyone has raised their hand. Some of you might also be on email. I don't use email that much, but I hear that's a very popular thing for the kids today with their social networks. They have Facebook and email. I don't know. So if you want to talk to me on email, there I am there as well, josh@joshlong.com. I'm also an author and a video lecturer, so I've done these trainings on the live lessons series on the Safari online marketplace. The latest and greatest of which is Building Microservices with Spring Boot Live Lessons by my friend and Spring Boot co-founder Phil Webb and myself. And my latest book is from O'Reilly. It's called Cloud Native Java, which of course is the name of the session that we're going to go through today. Cloud Native Java has as the animal on the cover. I know most of you are wondering. It has as the animal the blue-eared kingfisher from the Javanesian islands. Right, so it's a bird in the clouds, and it flies from Java. Get it? No? Okay. It's fine. Anyway, that's my animal. I had to ask a lot of favors to get that cool animal, so I'm very proud of that. Anyway, I work at Pivotal. I don't know if you know of Pivotal. Some people do, some people don't. I feel like we have done a really crap job of explaining what Pivotal is and where it is and so on. It's the home of lots of great technologies, lots of technologies that you probably already use. So, for example, Spring, right? Spring is out there. It's very, very ubiquitous. It's very useful. Apache Tomcat, right? We have the leadership in the Apache Tomcat code base, for example. Cloud Foundry. Now, Cloud Foundry is an open source platform. It's a way of continuously and safely delivering applications to production. And that's very important to us at Pivotal. That's our raison d'etre. That's why we wake up every morning very excited, very happy, is because we help customers, community, and so on quickly and safely deliver applications to production. That is what we think about all the time. All of this open source software, as useful as it is only useful in that it helps our customers and our community quickly and safely deliver applications to production. The goal is hard, though. We've seen that a lot of organizations struggle with delivering applications quickly and safely to production. Everything all right, guys? Yeah. We've seen that a lot of organizations struggle with quickly and safely delivering applications into production. They ask themselves, how can they take these large existing applications from yesteryear, from before the economics of cloud computing made sense? How can they quickly take these large, unbroken, monolithic applications and deliver them into production where they can deliver business value, where they can be de-risked, right? The longer you delay the delivery of business value delivering software into production, the longer you wait until you can validate whether that software is actually useful. And so this is, I think, very obvious. This is part of what we understand as part of the Agile manifesto, right? The faster we can go from concept all the way to production, the better, right? And so most organizations today are actually, in essence, a software factory. They have several different stations in the software factory. They start from product management, and then they go through user experience, and then they go through the developers, and then they go through the testers, and then they go through the various administrators, so system administrators, network administrators, LAN administrators, etc., etc., etc. And all of these stations in the factory are very important, but they take time, right? There's a queuing, there's a wait period before each station in the factory. So work flows from product management, and then when possible, somebody from the user experience team takes the work and works on it. And then they throw their work over the wall, and then it flows very slowly from there to the developers. And then they take their work, hopefully, and then when possible, the people from the testing group work on it. And so while each station may take only a few days or a few hours or whatever, it takes weeks or sometimes months for the work, the output, the product to be visible in production where it can actually deliver value. This is really, really, really bad because, again, you lose your chance to validate whether the software is useful if you wait until it's actually in production. That's the only true meaningful test of software is, does it validate when used in production? So organizations, they do what they can to go faster through the software factory. They, for example, will use a cloud computing platform, something like a Cloud Foundry, to automate away as much as possible of the administrators at the very end of the process. So all of the database and SAN and all this stuff gets hopefully automated, right? So now they can go through those steps much, much, much faster. Of course, there are other things they look to do as well. The artificial divide between operations and developers, that goes away as well, right? We have this idea of DevOps. DevOps is just a fancy word for empathy between team members. The idea is that these are different groups of people working on different sides of the same problem. They are not to be split, otherwise the solution will always be less than ideal. So these team members should work together in a closed circuit without any queuing time in between them. And eventually, organizations realize that if they can extrapolate or if they can grow this same process, instead of just throwing work over the wall from product management to the user experience and then to the developers and so on, if they can have these people all in the same room focused on one thing, they can go faster. And so the question is, what is that one thing? They can't all focus on just the whole application. So they need to find small batches of work, small pieces of functionality that they can move through the factory as quickly as possible, that they can iterate through as quickly as possible. And this small batch of work, they look for parts of the existing monolithic application that, when extracted from the main application, is still consistent. It's still internally consistent. This internally consistent part of the application is called a bounded context. If you've ever read Dr. Eric Evans's amazing book, Domain-Driven Design, then you know that a bounded context is a part of the domain model that is consistent within itself. It does not need any other part of the application. If you can find in your monolithic application a bounded context, then it's very easy to make that a separate piece of functionality. That's something that is independently deployed. It doesn't have to wait for other pieces of the code to be tested and integrated and then developed and so on. This small batch of work that is independently deployable, we call this a microservice. And so organizations look for these microservices. They want to be able to go as fast as they can from concept to production, no queuing. They want the whole team focused on one thing, no queuing in between. This is called a feature team. Amazon and Netflix have talked about this quite a bit. They say that the size of a feature team is what they say as 2 pizza boxes. And of course, I know here in France and in Belgium, the question about 2 pizza boxes is very different from 2 pizza boxes in America. But in America, 2 pizza boxes worth of food is for a very small team, right? 7 people, 5 to 7 people. Obviously, here you could feed a large soccer team, for example. So in America, that's a small team, and that includes product management, that includes the developers, that includes the testers, that includes the administrators. And the reason this is important is because you want to remove the cost of synchronization between team members. If I have to spend a lot of time discussing with the rest of my team what I'm doing, then I lose velocity. So the real metric of what a microservice is not to do with the size of the code. It is to do with the size of the team. How quickly can they iterate on that product, on that piece of functionality? So when you move into this world of small, singly focused, independently deployable, small batches of functionality, what you're really doing is you're building services, small, networked services. The boundary becomes a network boundary. And so while you do gain velocity, you do now add complexity to the process. Each new service has a lot of things that you must address over and over and over again in order to be able to deploy that service into production. These services are what we call non-functional or cross-functional requirements. Each service will have them, and then when you move into a distributed systems world, there are patterns that you must address as well, and these are also non-functional requirements. That is, they don't contribute to your organization's ability to deliver better functionality. Instead, they contribute to your organization's ability to run the software. It's not the same. You did not start a business. Nobody started a business, for example, to handle health checks, right? This is not an important part of your business, but it is important to the operations of the application. And these must be addressed on each new service. And so this creates a lot of pain. I'm sure that most of us know about the terrible wiki page in the organization, the wiki page with 5,000 easy steps to be able to deploy a new service to production. That is the enemy of velocity. And so while we want to stand up new services and while we want to build distributed systems, one thing should be very clear to all of us who have done this before. Distributed systems are hard. And so what we're going to look at today are patterns for addressing the complexity and standing up new services, and then patterns for addressing the complexity implied in building distributed systems. So those are my slides. I worked very hard on them. I hope you like them. For the balance of this talk, we're going to go through code, like I say. So I hope you grabbed that URL earlier. We're going to start our journey here at start.spring.io. Now, this is my second favorite place on the internet. There's two places on the internet that I just love more than anything. The first favorite place, of course, is production. So production, wherever that is my favorite place in the whole world. It's better than Disneyland. It's the happiest place on earth. You should go to Disneyland whenever you can. It's the greatest. I would take my family there if I could. The second favorite place, of course, is start.spring.io because it is the most efficient way that I know to get to production. So we're going to build a new service here, and again, we're going to go to start.spring.io. Start.spring.io is a very, very simple place for you to start your journey with Spring. You have options here. You have lots of options. You can choose, for example, which version of the technology you want to use, Maven or Gradle or whatever. You can choose which version of Spring Boot you want to use, so I'm going to leave the default. This is the latest stable version of Spring Boot. And you can give the service that want to create a name. I'm going to name mine the reservation service. And here you have options about, you have choices about which technologies you would like to use. So I will say, let's use the web support. I'm going to use the H2 in-memory database because I want to use a SQL database for fast prototyping. I'm going to use JPA, or the Java Persistence API, because I make poor life decisions, so JPA. I'm going to bring in the actuator for operational concerns. I'll bring in the config client for centralized configuration management. I'll bring in the Eureka service registration and discovery API. I'm going to bring in RabbitMQ stream processing. And I think that should be enough. Oh, I'm going to also bring in REST repository, so I'll bring that in as well. And then I can hit generate my project, or I can look at the full version of the options here. So I clicked on that link, and you can see there are other checkboxes that I have not selected. Many, many other checkboxes. So while I would love to be able to cover all of them tonight, we simply do not have the time. Remember those silly advertisements from Apple? There's an app for that. Screw that. More importantly, there's a checkbox for that, right? So find your checkbox, use it as you need to, be productive. Now, you have choices here as well. For example, you can select which version of Java you would like to use. Java 1.6, 1.7, or 1.8. Whatever you do, don't use Java 1.6 or 1.7. They are end-of-lifed unless you buy an extension for support from Oracle. And we all know how wonderful and generous and benevolent Oracle is. So don't do that. You have a choice about which language you would like to use. We don't care. Obviously, you can use any language. You can use Scala. You can use any language that supports annotations and objects. So there's that. I'm going to choose Java because that's what I think most people will know, and I am, after all, a Java champion, not a Kotlin champion. And then, of course, you have here a choice that a lot of people seem to find very confusing. Jar or war. Now, if by some terrible, strange accident you are stuck in the very, very distant past, unable to move forward to the future today, then by all means choose .war. But if you're here with me in 2016, then choose .jar. This is a big part of my personal philosophy of make jar, not war. Again, you have choices, you have options, you should do what's right for you. Now, I'm going to hit generate. I'm going to open up my little project here. I'm going to open this up in the IDE, and again, you can use any IDE you like. It doesn't really matter. You can use Eclipse, you can use NetBeans, you can use whatever you want. They're all great choices, right? So here we go. Ooh, I see I have a message. Any messages? There's a message. Does it work?
Let's see. We'll stop for a few minutes. Yes. On this screen, it's 1 minute gap. I see it works.
Well, what? This is bizarre.
Yeah. No, I can hear you. It's still streaming.
But
it's fine. It's just 1 minute late.
But that's more than a minute ago. That's like 5 minutes ago. Okay. What do you see? Like, he should have seen me at start.spring.io. Do you see start? Oh, God. You need to tell me this, people.
Yes, so the audio is 1 minute. The screen is not.
Well, I've been talking for 10 minutes and this has been the wrong side.
We hebben al gezien, tot als...
The
The people here have been seeing everything you've been saying, so it's on the stream.
What do they see?
Yeah, everything up till now.
Everything on up until now.
Okay, did you see start.spring.io?
We're still seeing this, by the way.
What?
Yep.
Did you see start.spring.io for the last like 10 minutes?
Yeah.
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 Yeah, it was a nice talk.
Okay, if there's an issue, please, I won't be able to see the Skype, so can you please ping my colleagues?
Yep, sure, we will.
And they'll stop me.
Sure.
Okay. Okay, anyway, you can open this up and use it in any ID you want. Let's see. There we go. Okay. Good. Okay, I'm just weirded out because I was worried that my screen was not sharing all of this time. Okay, so you can open this up in any IDE you want. It's okay, it doesn't really matter. If you're using NetBeans, that's fine. If you're using Eclipse, that's fine. If you're using IntelliJ, that's fine. You can even use Emacs, and I know that the guy who uses Emacs is in my audience all the time. He follows me around every country I go to. I don't know how he does it, but he is an amazing traveler. Now, I have opened this up in my ID, and again, it's just a regular Spring Boot application. I'm not sure how many of you have seen Spring Boot, but what you should know is that my Maven build is very simple. I have a parent POM here, a parent build, and then I have here, inside the parent build, another dependency on Spring Boot dependencies, where you will find that we have leveled or straightened or set or fixed the common versions for common ecosystem projects like, for example, AspectJ and Atomicos and Bitronics, both of which are from Belgium, of course, and Derby and DropWizard and Flyway and Liquibase and Hazelcast and Hibernate and Jackson and Java Assist, all these common libraries. So we have played whack-a-mole. We have made sure that if there's ever a version discrepancy between Project A and Project B on a shared dependency Project C, that they are the same version. Then the benefit, of course, is that when you use Spring Boot, you don't have to qualify the versions here. So I'm using Spring Boot Starter Actuator, and Spring Boot Starter Actuator is it brings in everything I need for that, right? If I use Spring Boot Starter Data JPA, it brings in everything I need in 2016 to use JPA effectively. It brings in Hibernate 5.x, it brings in the JPA 2.x specification, it brings in transaction support and JPA support and ORM support from Spring. It brings in everything, right? So I don't need to worry about setting all this stuff up. I get velocity through consistency in my projects. Now, for our first example, our first application, we're going to start very simple. I'm going to build a very simple application that manages entities of type reservation. So here I'll say class reservation, and I'll give it a primary key. I'll say private long ID, and I'll give it another field called reservation name. Okay, reservation name, and the ID here will be a primary key. I'll signal that it is a primary key by using the JPA annotations ID and generated value. I'll also add some accessors, and I'll add some constructors, again, because I want to, this is Java, so in Java, of course, this is the essence of what I want to express. The rest of this is just for Java, right? So here's another constructor, this time for JPA, right? Okay, and then I'll add a toString method. There we go, so we have something to work with. I'll tell JPA that this is an entity by annotating it with javax.persistent.entity. And now I have something that will be stored in the database under a table called reservations with a primary key column, a generated value column called ID, and a field called reservation underscore name. I want to be able to work with this data quickly, so I want to use a repository object. If you've ever read Dr. Eric Evans's amazing book, Domain-Driven Design, then you know that a repository is an object that sits between the underlying persistence tier and the client business code. So here, I'm going to say reservation repository. Now, I'm going to use an interface, and the reason I'm using an interface is because I'm going to use Spring data repositories. Typical repository objects are very boring. They have absolutely no business value. No one will ever come to you and put their hand on your shoulder and say, good job, well done. You did a great job writing that select all from foo where ID equals question mark query. No one's going to ever do that. This is undifferentiated business value. It'll never ever contribute to your standing in the market or to your ability to compete with competitors. So why write that code in the first place? It's dumb code. Instead, let's go ahead and let the machine do the dumb work. We're going to define this interface here. We'll say we'll benefit from the fact that the JPA repository itself has methods for find all given a sorting condition, find all given a collection of IDs, save, flush, delete, etc., etc., etc. This is not a common abstraction that is supposed to be the same across all technologies. However, JPA, because it builds on top of RDBMSs, which is of course SQL, is very useful for ad hoc paging and sorting type of queries. Of course, Cassandra and the Cassandra repository will not have similar support because Cassandra doesn't do a very good job with ad hoc paging and sorting. We also support the best of breed features. So for example, I can declare a finder method here, a custom finder method that Spring Data will implement for me by convention. So I can say find by reservation name. And at runtime, this will be churned into a query, something like select all from reservations where reservation underscore name equals RN. Of course, I can use a custom query annotation to override the query that's used to drive this method, but in our case, it suffices to let the convention do the work for us. Find by reservation name. Find reservations by reservation name, right? That'll work correctly. If I wanted to, for example, if I were using MongoDB or Couchbase, I could use the geospatial queries, for example, because Spring Data also knows about the best of breed features from these technologies, not just the common abstraction between them all. Okay, so now I have an interface, I have a repository, I can inject that repository into code if I want to. I'm going to create a component. I'll create a class called dummy CLR that'll implement command line runner. Now, command line runner is a interface in Spring Boot. It has one simple job. Whenever this interface is implemented, Spring will call the run method, passing in as the arguments the public static void main string args from here. into the callback method. This makes this an ideal place to do initialization, batch or ETL or any kind of non-HTTP workload. You can start it off there, right? Because this is a Spring Bean, it's just a regular class that Spring will manage for us. And the reason it will do this is because Spring sees this stereotype marker annotation. There's another way to define a bean, of course. We can do a bean provider method. So both ways will work. In this case, we can start with a component annotation, and Spring will automatically scan this package that we're in because of this annotation, and it'll find all of the beans under column.example that have stereotype annotations, and it'll manage those beans for us. I can tell Spring to satisfy lifecycle methods, for example, initialization and destruction callbacks, or this void run method, for example. And I can rely on Spring to also satisfy dependencies on collaborating objects. The correct way to declare a dependency on a collaborating object like the reservation repository is to declare a private final field and then create a constructor and then specify in the constructor that it's to be auto-wired, that is, that the arguments are to be satisfied when the class is instantiated. This is the correct way, and this is what you should always do. I'm not going to do that. Instead, I'm going to use field injection, and the reason is because, first of all, I'm very lazy. Very lazy. I mean, so lazy. But also, I don't have a lot of space on my screen. So I don't want you to do this. Not even when you're all by yourself at home, all alone, and no one is looking. Never, ever do this. Every time you do this, a unit test will die. Okay? I'm going to do that so I can just be quick and go quickly. Okay? So I'm going to say stream of, and I'll say Didier, and I'll say John, and I'll say Marie, and I'll say Josh, and I need some more names. Some more names, please. Marcel, Emmanuel. Can you give me some more names?
Alex,
Yeah, there we go. More.
Sylvain,
Comment ça s'appelle?
Sylvain.
Comme ça, okay. Merci, thank you. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it's asymmetrical. I could never sleep at night. So okay, we'll fix it. There we go. So now I have exactly. What did I say? 6, 7. No, I have 1, 2, 3. Oh, it wasn't asymmetrical. That's fine. I can leave it back. There. Yeah, there's 8. So I'm going to say, for each name, pass the name into this callback lambda. And then in the lambda, I'm going to back, and I can say system.out.println, right? This is, again, a nice feature in Java 8. It's very, very powerful. The idea is that I want to express to the JDK just the essence of what I'm trying to do, which is I want the parameter list here, and I want the method body here. That's called a lambda. Lambdas are a feature that only very modern languages like C, Smalltalk, PHP, Perl, Lisp, COBOL, Objective-C, F#, Basic, C#, Camel, OCaml, C++, Basic, JavaScript, Ruby, Python, Perl. Only these modern languages, and languages like Haskell, for example, only these modern languages have this feature. So I'm very happy as a Java champion to stand before you today and talk about a feature that was added to Java in 2013. This makes me very happy. So here we are. We have lambdas now. Okay, so if I run this application, we should see that it is connected to a data source, and the data source, of course, will be automatically created for us by Spring Boot because we have the H2 in-memory database on the class path. So here on the output, here is the results that we expected, and of course that worked. I don't know what you were expecting. This was always going to work. This was a demonstration, and I don't usually make mistakes. Instead, what I really wanted to talk to you about was this. Now, this is the ASCII artwork inside of Spring Boot. On the Spring team, we have several people who are doctors. PhDs. They worked in their previous lives on nuclear physics. So it makes me very happy to imagine that someday, somewhere, somehow, they got a GitHub issue saying, damn it, we need good ASCII artwork. And look at this. It's absolutely beautiful. I'm sure you will agree. Now, sometimes people ask me stupid questions. They say, can I change the ASCII artwork? And I say, that's a stupid question. Can you please try again? And I get very upset because why would you ever want to get rid of this beautiful ASCII artwork? And it's at this point that I would like to take a moment and just talk about a feature that was added into Spring Boot into IntelliJ that, while I'm a big fan of the product, I feel is really, really dumb. What is this? Why is this here? This is the dumbest thing I've ever seen. It makes me very sad that this is even here. We should be able to get rid of it. Anyway, we can get rid of it. We can change it. If you are really, really gifted and you know how to change it, then only then can you make the change. So we're going to go ahead and look at how to do that. I'm going to change the banner here. So I'll say copy, desktop, downloads, reservation service, source main, resources. Okay. And what has happened is I've copied the output here to the source main resources banner.txt directory or file in my local application. And now I will restart the application. And you can see here that I have much better banner ASCII artwork. But again, you must use care when making this decision, not to be taken lightly. There are a few things that I love about this ASCII artwork. First of all, meow. And also this. I wish I could show you I wish I could zoom in and show you this, but what is it doing? Okay, there you go. So it's coming. I wish I could zoom in and show you this, but it seems like my screen doesn't correctly zoom in and zoom out when I'm using Skype, which is sad. It makes me very sad. Okay, anyway, we have an application. It's writing data to the database. We've got basic support for reading and writing. We've got some sample data. And so this is all very well and good. It is 2016, however, and as you know, there's an existential sort of philosophy discussion to have here. If I write data to the database, but I cannot read that data from the REST API, did I actually write the data to the database? And of course, the answer that we all, I'm sure, understand is no. No, you didn't. So we're going to go ahead and bring in Spring Boot Starter Web and Spring Boot Starter Data REST to help us build a REST API very quickly. Here we are. I'm going to say REST controller, for example. REST controller. Come on. REST controller class. Reservation REST controller. And I will inject my collaborator, my reservation repository. So there's this. So there we go. Okay, and I will create a method to return the information from the repository. I'll say reservations, return this dot reservation repository dot find all. I'll say add request mapping, and I'll say method equals get and value equals reservations, and then we'll restart having done all the hard work to be able to expose the data from the database through an endpoint called reservations. When I go to my browser, localhost 8080/reservations, you'll see that the results show up as we expect very quickly. But this is actually a lot of extra work. What I really want to do is to take the business state transitions that my repository already knows how to handle and then map those to the HTTP verbs. That is, after all, the very nature, the essence of REST. So I'm going to go ahead and remove all of this stupid code and use Spring Data REST to make my repository a REST endpoint. So I'll say REST repository REST resource, and I'll annotate this. I'll say at REST resource, path equals by name, and then I'll annotate my parameter here. I'll say at param rn, and then I'll restart again. This time, hopefully we'll see that we get all of that work done for us automatically. Okay. Now, if I revisit the endpoint here, you can see that I have the same basic data as I had before, except now I also have these links. These links are hypermedia. They're an implementation of the design pattern called HATEOS, H-A-T-E-O-A-S, hypermedia as the engine of application state. It's the idea that every REST resource, every REST response, should have in the body of the REST response enough information for the client, that is to say, the browser or the API client, to be able to use that REST resource without any a priori knowledge, right? This is very, very common. We do this all of the time, whether we know it or not. If you use an HTML page today, a modern HTML page, you'll see in the HTML markup a link element with a rel tag and a source, foo.css, for example. Here, in this link element, the browser is able to dereference the final URL for the style sheet. It knows that this style sheet lives at this URL, but the relevance of the style sheet is explained by the rel attribute, right? The browser does not have to know where to look for the style sheet. It does not have to know before the page is loaded where the style sheet lives, right? It does not have a deep link into the API of the style, or rather the URL of the style sheet. The browser loads the link, and then the link tells it where to go. If the style sheet moves its location tomorrow, the browser is going to be just fine because the browser will change the link. The client will see the new link and get the new URL. This way, the API topology, the structure of the APIs can change and the clients are not broken. This promotes long-lived, self-describing REST APIs. These links also provide us the ability to imply state. Imagine you're on Amazon.com and you add products to a shopping cart. Do you imagine that Amazon.com will show you links for products that you have not paid for, that let you take those products and then get a refund? You know, why would they? Of course not. They would never show you a way to get money back for something for which you have not paid. These links only appear after you have paid for them. Similarly, here, our hypermedia API only shows links when it's appropriate, so you can contribute custom links here. We can see that these links are domain and resource specific, but I can see, for example, if I go down to the bottom for the whole reservations endpoint, that there is a search link. And if I go to the search endpoint, I can see that I can search by name. So search by name, question mark, RN equals, let's find a name here that I have already forgotten. And we'll take DDA, there we go. And if I do a search for by DDA, I can see that the results come back for just him, and I can see how to get back to that search result and so on. I can see that if I want to get to the canonical representation of that entity, I go to reservations/1. I can also see that I can do paging. So reservations, question mark, page equals 1, and size equals 2. There are 2 records that come back, and when I go down, I look at the links. I can see there are links that tell me where to go relative to the current page of results, right? All of this is automatic. We are using Spring Data REST to build this hypermedia API, but Spring Data REST underneath uses something called Spring HATEOS. A very important part of Spring HATEOS is the idea of a resource. Each representation here is actually a resource with a payload, the object that it's representing, and then links about that payload, right? So payload and then links inside the resource. The resource is an envelope. It contains the stuff inside of it. We'll look at this later on. We'll see later on what we can do with that resource. So keep that in the back of your mind for later on, okay? Now, we have a basic, simple REST API. We can talk to it. It's got some data. It's already very, very useful. But can we deploy this to production? Probably not, right? There are things that we need to address that are not business differentiating functionality, but that still need to be addressed. For example, how does our application, to forgive the image, but how does the application scream? How do we know if something's wrong? Your software, when it is in production and it's doing, and if it's happy and everything's great, your software makes the same sound when it's happy as when it is dead, right? No sound at all. There's no smell that your software will make. It doesn't have any visible signs by default that everything is okay. You need to teach that software how to explain itself. Things like metrics give you that ability. Health checks that give you that ability. Enumerations of the environment give you that ability. So we're going to use the Spring Boot Starter Actuator dependency to contribute all of these operational endpoints, these actuator endpoints. So now, if I revisit my REST API here, and I go to /, for example, and if I go to reservations /2, and then 4, and then 6, etc., right? And then if I go down to / again, and I go down to /metrics, /metrics is an endpoint that enumerates useful keys and values about the environment, numbers that have been automatically collected for us. So for example, how much memory we have on this host, how many processors, the uptime, how much memory is free, the heap, the non-heap, the classes that have been loaded, etc. You can create your own custom metrics as well. So for example, if you want to record how many users are connected to the server, or how many products have been added to the shopping cart, and so on. There are two different ways to do this. You can inject in any of your code, you can inject an object of type counter service. A counter service is useful for collecting deltas. You can say +1 or -1, right? So for each request, you may use a counter to collect or to calculate how many requests there are. If you use the gauge, GAUGE service, you can collect absolute numbers. This is useful, for example, for counting, for example, how many users are connected to the server, or how much memory you have, or whatever, something that you can calculate the whole value for right now. These are useful by themselves, and you can see that here, this is all collected very neatly for us. We also have things like the counters for each request made into the system. Here we can see that we have made 2 requests to the / endpoint, the root of the URL, with status code 200. We have made 6 requests to reservations, and we have status code 200. These are very useful, but they miss a very important dimension. They are missing or lacking the dimension of time. Time is the only way that we can contextualize these values. It's the only way that we know whether something is improved or deteriorated. We can add time by using a histogram. In order to get that, we can add, for example, the drop wizard metrics library to the class path. The drop wizard metrics library is a separate third-party library created by the CodaHail metric. It's called the CodaHail or Yammer or drop wizard metrics library. It was originally created by Yammer when they wanted to operationalize their application. A histogram is a statistical structure. It keeps information, samples of numbers, over time. This gives you the ability to reason about the progress of the application. It collects, for example, the average, the mean, the median, the max, the minimum, the 95th percentile, the 99th percentile, the 99.9 percentile, etc. These numbers are collected for you over time using a process called statistical sampling. Now, with these numbers, you can see whether this number is an outlier. That is to say, is it more than usual or less than usual? Is it the same, etc.? These help you understand whether something is good or bad, whether it's an improvement or not an improvement. There's another kind of metric that the drop wizard metrics library can help you with. It's called a timer. The timer is used to capture the time a certain transaction or request has taken. The timer metric in the drop wizard metrics library keeps a histogram of timings. It's a specialized histogram specifically for timings. So you can see, for example, for all requests at a certain REST endpoint, whether that request took a lot longer than the average time or less or whatever. So keep that in mind. Spring's actuator also supports publishing metrics, right? As useful as these metrics are, right now we are only looking at them inside of our REST endpoint. I want to be able to visualize these metrics. I want to be able to see them in a single place and get a joined up view. The joined up view is great for a dashboard. When you build a distributed system, it's imperative that you have what's called a single pane of glass, a single place where you can see all of this information. Metrics on a host by host basis don't help. Right? We need to centralize this information, to aggregate this information. And so Spring Boot supports the metrics writer hierarchy. There are a few very useful implementations that come out of the box. For example, there's one that writes metrics to Redis, right? To the Redis distributed key value store. There's another one that writes metrics using the StatsD protocol. The StatsD daemon was originally written by the folks at Etsy. It originally was written using Node.js. Node.js, as we know, is terribly unscalable, so nobody uses the daemon, but they do use the protocol. The protocol has become a de facto standard for publishing and sharing metrics. So if you're using Graphite, it speaks StatsD. If you're using OpenTSDB, it can speak StatsD. If you're using Datadog, it can speak StatsD, etc. So it's a very, very useful protocol, even if you're not using the StatsD daemon. If you would like more options, more advanced options, then the drop reserve metrics library has what are called metrics reporters. You can configure an appropriate bean from the drop reserve metrics library, and Spring Boot's actuator will automatically write all of the metrics to that reporter, just like it would to the metrics writer if you configured one of those. Okay, so here's the counter. These are metrics, right? I want to see, for example, a deeper look. I want a more involved, more detailed look at how many requests have been made and the nature of those requests. I can go to /trace. /trace shows me the timestamps, the HTTP verbs, the headers, the content, and so on. This is limited by default to the last 100 requests. Of course, you can configure all of this as you wish. I can go to the info endpoint. Now, info is empty on purpose. It's because you are meant to customize this endpoint. For example, you may use the Maven git commit ID plugin to write out the commit ID of the resource, of the build. Imagine you're doing continuous delivery. In continuous delivery pipelines, a git commit and push, or a subversion commit, translates into something that gets pushed through a pipeline. Each stage of the pipeline contains more aggressive, more exhaustive, more detailed tests. If the code manages to go from the very beginning of the pipeline all the way to the finish line, it's possible to then push that code into production. If you automatically push it to production, that is called continuous deployment. Continuous deployment is a very, very good thing to get to if you can. But in order to do that, you must be able to reason about the version of the software that is in production. You must be able to see which git commit triggered the build that ultimately resulted in a push to production. So the info endpoint is a great tool for exposing that information. We also have the mappings endpoint. The mappings endpoint shows all of the Spring MVC or Spring exposed HTTP endpoints, as well as the metadata or configuration about the or for the request itself. So, for example, we can see that the env endpoint only responds to HTTP GET, and it produces application JSON. We can also go to the beans endpoint, and beans shows you the wiring of all of the objects, how these objects are arranged together, how they are composed together in the application. You can also see which dependencies they have, the location of the class file on the file system, the scope, etc. Right? And of course, we have the health endpoint, and the health endpoint is just that. It tells us the health of the application based on the components in the application. Each component in the health indicator here contributes its own status. So we have a disk space health indicator that tells us the state of the disk of the file system, as well as the status, up, down, whatever. We also have a data source automatically configured for us by Spring Boot. The data source has a connection pool. The connection pool has a validation query. Select one from dual, or just select one. The result of that validation query is shown here, hello:1. If the disk space health indicator says down, then the global health indicator will also say down, right? So we have a lot of great, very, very powerful health, metrics and health and beans, all these actuator endpoints that we can use to understand the state of the application. However, we should customize some of the stuff. You may want to change some of the default behavior. For example, suppose that I want my metrics endpoint and my health endpoint to not be exposed at /. I want them to be at /admin. And also, what if I want to contribute my own custom health indicator? Let's look at a few different ways that Spring Boot makes it easy to override the default behavior of the application. We'll go to application.properties, which is a text file that's in the source main resources directory. Spring Boot looks for this file by default. You can change a lot of different things. You can say, for example, that you want to change, you want to enable debugging. So you can say debug equals false. You can change the character set for the banner, or change where it's supposed to look for the banner.txt. You can change all sorts of things based on these properties. If you want to find out which properties are available, you can just visit config props. It's another actuator endpoint. I'm using an IntelliJ Ultimate, and it has auto configuration. There's a plugin for NetBeans called Spring Boot Tools for NetBeans, and the Spring Tool Suite all have similar support. They can all do auto completion. But if you don't have one of those tools, you go to the config props endpoint, and you can see here, for example, the properties that are available and their possible options. So suppose I want to change the URL for the management endpoints, the admin, the actuator, the metrics, etc. I can see here that there's a property called management, and if I start my property with management.contextPath, or management.security, or management.address, or management.port, etc., 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 then I can change the way the application behaves. So let's go ahead and do that. We'll say management.contextPath equals admin. Notice that I used context-path here, but in the config props endpoint, it showed me this. These are the same thing. Spring Boot will normalize them at startup, and so you can use either one and it'll work. So this is one way of changing the behavior of the application. We can also just use dependency injection. We can contribute custom objects to control or change how Spring Boot does its work. Here, I'm going to define an object of type health indicator. Now, this is a bean provider method. Before, I used a component annotation to tell Spring that I wanted it to instantiate an instance of this dummy CLR. Here, I'm telling Spring that we will create our own health indicator, and we will instantiate it and configure it, but we still want Spring to manage the lifecycle and to satisfy any dependencies where appropriate. So here, I'm going to create my own health indicator object, and I'll say that the status, the health, is, dot down, or dot up, or out of service, etc. Here I will just say je suis Bruxelles. There, okay? There's my custom status, okay? And of course, this is a very, very good candidate for Lambda. So there we go. By the way, if you don't specify a status here, then if you just say status, then of course the status is up, and we are definitely up, okay? I will restart, and now we should be able to see reflected in the output our customizations. Okay, let's go to :8080 /admin /health. There we are, right? Je l'ai mal appelé. Is it 1x or 2x?
X.
Bruxelles?
Bruxelles.
Oh, I'm sorry.
Yeah. No.
Photo de orthography. Pardon. Okay. Allez.
French.
Yeah.
French speaking. Or in English, it's brew.
Cells. With abacus. Yeah. Je l'ai oublié. Okay. Anton, je le corrige, mais quand même. So here it is. Here's the health indicator representing a custom status. Everything's fine. And we can see that the endpoints are now underneath /admin. So this is good. We have now got an application that we can very easily move to production if we want to. We can change how this application behaves by overriding these properties, or if we want to, we can also change these properties external to the application. This is very important in a cloud-native application. Here's my application in my desktop, in my downloads directory here. I say maven clean install, and I will build it very quickly. I'll say skip tests equals true. Okay. And I'll go to the target directory, and here I can see that I have a a fat jar, right? This jar, this jar has everything it needs to run, right? It is a self-contained jar. I can very easily run it with java -jar reservation service.jar, and here I can see the output and so on. I can override, I can also take this application very easily to production. I can say, for example, cf push -p reservation service.jar my Belgian jar, right? So I'm going to now deploy this to a cloud called Cloud Foundry. And again, I'm using Cloud Foundry because it's what I know and it works. But again, very easy to move this to any cloud environment because everything is inside that jar already. I can now also change things very easily. If I want to override, for example, the server port, I can say server.port in application.properties, right? But of course, if I did that, I would have to recompile the jar every single time. So instead of doing it in application.properties, I will say java -d server.port equals 8010 -jar reservation service.jar. So there's the application spinning up on port, what did I say, 8010, right? Yes, there it is right there. So 8010. So that works, and it's very, very simple. Of course, that's one way to change the information. I can also say export server_port equals 8030 java -jar reservation service 001 -jar, right? And this is an environment variable, but it's being used by Spring Boot to change the environment variable, to change the property. Again, it's being normalized, into a property called server.port. This is very, very useful. It means that I can move my binary from development to production to Q&A to whatever into production without recompiling the code. I am now taking advantage of something called 12-factor style configuration. This is the idea that things that change from one environment to another should be external to the application. Okay, so the application, by the way, that I've just deployed is now running on Cloud Foundry. Right? You can see how very quick that was. So here it is, my Belgian jar cfapps.io, reservations, etc. And there's my data on the Cloud Foundry application. So again, the idea is that we've gone very quickly from building an API, we've handled operational concerns, and by leveraging a best-of-breed cloud computing technology like Cloud Foundry, we are already in production. Right? If you are spending more time than this, you are wasting time. I cannot stress that enough. So we have customized the application. We've used 12-factor style configuration, and this is good. This is a very good start. Factor style compatible application. But there are some things that are not already solved out of the box using what we have done so far. For example, how do I centralize my configuration? If I want configuration to be in one place, I don't want to have to revisit every single application manifest or startup script or whatever just to change the configuration. I'd like to be able to also have journaling and versioning. For example, if I change a property, I want to be able to see who changed the property, and I want to be able to see when they changed the property. And if necessary, I want to be able to roll it back. Also, how do I support auditing and journaling? That's exactly what I just talked about. How do I support that? I can use a version control, for example. That's one way to do it. Another very interesting use case is changing properties live at runtime. How do I change a property while the system is still running without restarting it? And another use case is, what if I have properties on the file system? Very important, sensitive properties like my password. How do I change those properties? How do I change those properties and read those properties without having them in plain text on the file system? So to support all of these use cases, I need something a little bit more sophisticated. What we have so far can definitely be a foundation, but it would be nice if we did not have to recreate this every single time we created a service. So to support this, I will go back to the Spring initializer, start.spring.io, and I'll build a new service called the config service. I'll say config server, and I'll hit generate. I'll open this up. Is that? Okay, and I'll open this up here. I'll say config service application, and I will say @enable config server. Okay. And once I've done that, I will configure where the application finds the property files that it's going to manage. So I'll say Spring Cloud config server.get.uri equals, right? And I will point it to my home directory, which is an environment variable, which we're going to reference here in the property file by using property placeholder resolution /desktop/config, right? So here it is, desktop config. There are all the properties on the file system, right? These are just property files that I want to be able to read centrally. This file system is managed by Git. It also could be Subversion, and this also could be an HTTP URL, GitHub or GitLab or whatever you want, right? I'm also going to change the port. I'll say server.port equals 8888. Server.port equals 88 will be how the application starts up on which port, right? So let's see. Here we go. So there we go. It's on port 8888, localhost 8888. And we can now see that if I am a microservice and my name, if I identify myself as reservation service, I can see the configuration for that microservice in the config repository, localhost :8888 /reservation service /defaults. Here you can see there are two sets of properties, two property sources. One property source is the desktop config folder /application.properties. Here you'll find keys and values that will be seen or visible to all microservices, regardless of where, regardless of how they have named themselves. Any microservice that connects to the config server will see the configuration from application.properties. Only the microservice that identifies itself as reservation-service will see the configuration from reservation-service.properties. If there is a conflict here, for example, server.port and server.port, then the more specific file, reservation-service.properties, will override the less specific file. So here we'll see that our microservice, if we connect to the config server to get our configuration, will have the port 8000. And it'll start up and it'll have the ability to use a message called, with the string, hello world. So let's now connect or configure our microservice, our reservation service, to talk to the Spring Cloud config server. First, we'll use the Spring Cloud config client. We'll say Spring Cloud starter config and add that onto the class path. And then we need to tell the microservice where to find the configuration. And again, we can do this in application.properties. We say Spring Cloud config URI equals HTTP : / localhost 8888. We must also give our microservice a name. So Spring application name equals reservation-service. Now, this information is all that you have to specify when you build a new microservice. Each microservice will have just these two values, the name of the microservice and where to find the rest of the information. Of course, this information is used before the rest of the configuration is used. It's used when the application is bootstrapping. By convention, Spring Cloud will look for this configuration in a property file called bootstrap.properties on the class path. Okay? So that's all you need to do. That's all we need to do to be able to draw the configuration in from the config server running in a separate process. Let's take advantage of that. Let's go ahead and build a REST endpoint here called message REST controller. And we will inject the message. We'll say @value $message, okay, private string message, curly bracket, and we'll say at request mapping, method equals get, value equals message, okay? And all I'm gonna do is just return the message that we've injected here from the config server. But of course, it's a good message, but I may want to change this message from time to time. So I want to make this endpoint, this REST API, refreshable so that I can change the configuration of the key and the value without having to restart the process. Now that I've done that, let's go ahead and restart the application. And let's see if it all worked. First of all, we should expect to see the application start on port 8000. And there it is, right? We can see now that it has indeed started on port 8000. If we go to localhost 8000 / message, you can see there's our message, hello world. But is that really the best message we can do? I mean, given the context, understanding where we are, and so on. So I'm going to go ahead to the configuration repository, the directory on my file system, and I'm going to open up Atom, which is a text editor, and I'll open up reservation service.properties, and I'll change the message. Okay, so we'll say bonjour, Bruxelles. There we are, and I'm going to add extra exclamation marks. Okay, this gives me more authority on Reddit, so that's very important. Extra exclamation marks. There we go. There we go. So now I'll say git commit -a -m YOLO. Okay, and once I have done that, the change is immediately visible here. If I go to the config server, I can see bonjour Bruxelles with my extra exclamation marks in the output there. But my REST API does not see the change yet. Nothing has happened. I need to force that endpoint to reconfigure itself, to refresh itself. Thankfully, this is easy to do. There are a few ways to do this. You can use, for example, the Spring Cloud event bus, so that whenever a file is changed, a message gets published, and the messages are sent to all of the microservices connected to the event bus, and they will then call their own refresh endpoint. Or we can do it explicitly, as we will here. I'm going to say curl -d curly bracket. That means empty HTTP post : / localhost 8000 / refresh. This is an actuator endpoint. Sorry about that. This is an actuator endpoint that is contributed by Spring Cloud. Again, so we're gonna go ahead and call it and refresh, and voila. Suddenly, when I hit refresh, it can see the new message, right? I can see that this key called message was changed, and the result is immediately visible in the output on the edge service here, right? Now then, let's go back to our code and deal with another problem that we're going to have if we start moving to a distributed systems world: the problem of service registration and discovery. This isn't a problem unless we want to take advantage of client-side load balancing. And the reason we want client-side load balancing is because load balancing options are typically very limited. And DNS itself is also very limited. Here's a few reasons why. If I use DNS and I make a request to a service that's behind a load balancer, and the load balancer is mapped to a DNS endpoint, I have no guarantee that some service will be able to respond to my request on the other side. I must make the request and then hope that something is there on the other side. If there are 0 instances of the service available, then the load balancer will just block. My request will be stopped, and I will wait for the request, probably for a very long time. Hopefully, I have done the right thing, and I have added, I've added timeouts to all of my REST clients, all of my client APIs. But again, most of us tend to forget this kind of thing. I think the java.net.url connection, the timeout for that's like 1 minute. I mean, even that is a very, very long time. 10 minutes. Oof. Yeah, I was just told it might 60 seconds. That's 1 minute. 10 minutes.
600.
600 seconds. Yeah, that's too long. If each of your client threads calls a service and blocks for 10 minutes or a minute or whatever, your thread pool in the server will very quickly become exhausted, and your service will die, right? And it'll be a domino effect. So it's much better to be able to ask the question, is anybody there? And if not, to then do something differently, right? We also want to be able to support customized load balancing scenarios. So your average Big 5 router, for example, will have a simple checkbox for round-robin load balancing. It'll load balance across all of the available instances in the ensemble. However, what about more business case specific load balancing scenarios? Suppose that I am like Netflix and I have streaming video coming from a certain node, and it's stateful, right? I'm not doing round robin requests for long running processes like streaming video. I want to be able to route OAuth tokens from the edge, from the outside of the services, to that single specific node, and then if necessary to fail over. How do I do data center availability aware load balancing, data center sensitive load balancing? For example, to load balance from Amazon East to Amazon West. How do I do multi-tenancy? Maybe I have certain nodes with data next to it, and I want to route requests to those specific nodes. Again, these are all use cases that you will not get out of the box with your average Big 5 router or whatever, right? You need the ability to make that decision on the client, before you make the request in Java code. So to support all of these, we need some way of talking about other services, of referencing other services without being coupled to where those services live. And we could, as I say, we could use DNS, but DNS is, by its very nature, it is designed to be cached. You are going against the system if you try and defeat that caching. And like I say, it's also very dumb. It cannot answer questions like, is there something on the other side? So we need something a little different. We're going to use what's called a service registry. A service registry is like a phone book. You ask it, here is the service ID that I want to talk to. What hosts and ports does that service live on? And you can get that collection, that enumeration of services, and then make the decision about which node to route the request to. We have in Spring Cloud support for many common service registries. Right now, the most, I think, my personal opinion, the most trustworthy and bulletproof is Eureka from Netflix. Eureka has been used at scale for many, many, many years at crazy scale. So it is very battle tested. There are others, of course. You can use Consul. You can use Apache Zookeeper. You can use, if you want, you can use the incubator code for etcd, etc. Right? I like Eureka though because, as I say, it's also very, very bulletproof and it's super simple to get started with. You can, for example, go to start.spring.io and set up a new Eureka service using Spring Cloud. So I'll say Eureka server, and of course my Eureka server will configure itself using the config server. So I'll add the config client, and then I'll hit generate project, and we're off to the races. Let's see now. 1 second. Okay, now, here's my Eureka service. I'm going to open this up in my IDE as usual. And I will configure it. I'll say that this is going to be a Eureka server, @enable Eureka server. I'll open up the application.properties and I'll say Spring Cloud config.uri equals http:// localhost 8888. And I will give this a name as usual. So spring.application name equals Eureka service. And as before, I will rename this file to bootstrap properties. Okay, there's this. I'll open up my Eureka service application and then start it up. And if everything goes according to the plan, this will start on port 8761. So localhost 8761. There we are. Le voilà. So you can see it's our Spring, it's the Spring Eureka integration, and it gives us some useful information. But one thing that we do not see here are services to connect to. Let's go ahead and revisit our reservation service and teach it how to connect to the Eureka service registry for availability, for connectivity. We're going to go back here to the reservation service, and I'll bring in the discovery client abstraction implementation for Eureka. I'll say Spring Cloud Starter Eureka. And then I will turn on the discovery client support by enabling the discovery client API. Okay, and I'll restart. And here we go. Here's the service registry, and as the service starts up, you'll see that it will eventually register itself here in the registry. So you can see reservation service, right, with one instance available at the moment on this host and service ID and port. So now we have our service, and we can build a client. So let's go ahead and do that. We're going to build a very special kind of client, something called an edge service. We shall name this the reservation client, and in the reservation client, we're going to use the Hystrix circuit breaker. We use the Zool micro proxy. We're going to use the config client. We're going to use Eureka service registration and discovery support. We're going to use web support, of course. We're going to use Actuator, of course. And we're going to use RabbitMQ for stream processing. Okay, and we're going to use Zipkin distributed tracing support. And so we'll hit generate, and we'll open this in our IDE as usual. Okay. And, same as before, we'll say @enable discovery client, and we'll say that this has to get its configuration from Spring Cloud config URI equals HTTP : localhost 8888 Spring dot application name equals reservation hyphen client, and we will rename this file to bootstrap.properties. Okay, and there's our application. Let's go ahead and start it up. Now, let's think about the kinds of edge services we want. An edge service is a service that lives outside of the rest of the application. It lives exposed to public traffic. Usually, there's one edge service per client. So you might, for example, have an HTML5 edge service, or an Android edge service, or an iOS edge service, or a PlayStation, or a Roku, or an Xbox, or a refrigerator, or a smart TV, or whatever, right? The edge service is a great place to handle client-specific concerns. As you know, especially now with the Internet of Things, data comes in all forms and shapes and sizes. The edge service is the right place to transform or translate requests from the outside to something that the inside services can use. Your microservices inside the data center, inside the cloud, should discover each other through the service registry. The edge service will be exposed via DNS, however. And so that edge service is going to be the first point of contact. It's the door into your application. Because of that, this is also a great place to handle security concerns. Each client has different kinds of security. Some have different kinds of protocols, and some need different kinds of payloads. You can handle all that at the edge service. Take, for example, an HTML5 application. HTML5 is a very capable, powerful environment, but it runs inside of a single sandbox. The sandbox restricts requests from outside of from the HTML5 application to services outside of the same origin host import. We can, of course, add a policy XML document to every single one of our microservices that let requests from out of the sandbox reach it, but that would be a lot of work. We would have to change every single microservice just to accommodate HTML5. If you have more than a handful of microservices, this is a terrible idea. You will lose the agility that we're trying to get from microservices in the first place. So instead, let's just proxy the requests from the outside to the backend of microservices using a reverse proxy, something called Zool. Zool is a project, it's a micro proxy from Netflix. And I'm sure if you have studied your Greek or Netflix mythology, or Ghostbusters mythology rather, then you know that Zool is the gatekeeper, right? So here is the monster called Zool, right? Zool is the guardian to hell, the proxy to the underworld. Okay. There's also, in the movie, Zool is the gatekeeper, and there was a keymaster, right? So that's what we're going to use. We're going to use the micro proxy called Zool. Zool is very simple. You just add the @enable Zool proxy annotation to your edge service and then start. And it already knows about all of the applications in your registry. You can map certain endpoints and proxy them to certain clients very specifically if you want, or to certain services, but we will just take advantage of the defaults here. If I start up the application, I now go to localhost 9999/reservation-service/reservations. So remember, reservation-service is the name of the service as it was registered in the service registry. If we had a service in the registry called foo-service, then we can type in foo service for the context path. This is the service ID that we used in the registry. And you can see that the proxy is already doing something useful. It's proxying the requests to the backend service. So everything that we specify here after / is proxied to the backend service directly. So the original service, of course, is on port 8000. We're accessing it from our edge service, our HTML5 edge service here on port 9999. We're also proxying the headers for the URL, and that's being used to write the links here. So the links are doing the correct thing. If you visit the actual service on port 8000 / reservations, you can see that there the links say localhost 8000. Here, the links say localhost 9999 / reservation-service. Very, very cool. Now, this might be enough. If you have an HTML5 application, you can add HTTP basic or OAuth authentication. You probably should add SSL, HTTPS, and then maybe you're done. Maybe that is enough. If you have an HTML5 application, it's a very powerful browser environment usually. You can do API protocol translation and aggregation and so on in the browser. There's no reason to move a lot of the heavy lifting to the server. However, sometimes you may want to have a subset of the data or a transformed view of the data. This requires a different kind of edge service, something called an API gateway. So the microproxy blindly forwards requests from the outside inside and then from the inside back. An API gateway does translation or transformation of some kind. It translates the protocol or the payload or whatever, right? It does security, etc. So here, we're going to build a very simple API gateway. We're going to build another REST controller, okay, REST controller, class, reservation, API gateway, and we're going to map this endpoint to @request mappings / reservation. So whenever somebody goes to / reservations on the edge service, and then we're going to create a new endpoint here called collection of string reservation names. Okay. And the endpoint here is going to be a sub mapping of the class level mapping. So whenever somebody goes to / reservations / names, this sub endpoint will be exposed and be invoked. And what we're going to do is we're going to make an HTTP request to the reservation service using REST. So we're going to use the REST template, which is an object in Spring that has been around in Spring since Spring 3.0 in 2009. And the REST template makes it very easy for one service to call another, in 1 or 2 lines. So here we can say return this. Well, we can say this dot REST template dot exchange HTTP : / reservation -service / reservations. Now again, we have something very cool here. What's happening here? This is not the server name in DNS. This is the service ID that we have in Eureka. When this request is made, the REST template has, thanks to Spring Cloud, a interceptor, an interceptor that is configured on the REST template. The REST template will take the URL, the service ID. It knows about the discovery client implementation for Eureka. So it will go to Eureka. It will ask the registry or Zookeeper or console, whatever. It'll ask the registry for all of the service instances in the registry. When it gets all of them back, it'll make the decision in the client code before the REST call is even made about which node to route the request to. The same thing is happening when we use our micro proxy here with Zool. When you make this request, the proxy goes to Eureka, looks up all of the service instances for the service called reservation-service, makes the decision about which node to route the request to on the client. This is called client-side load balancing. This is thanks to a component called Netflix Ribbon. Ribbon is a client-side load balancer, and it's automatically working for you it's out of the box right now. That's the same thing we'll see here. So I'm going to make an HTTP GET call, okay? And the GET is not a put or a post, so it has no body. We'll say no. And then the last value here is the parameterized type reference. We'll say parameterized type reference of resources of reservation. Now, what we want to do here is I want to be able to tell the REST template what kind of data I want back. There's a couple of ways to do this, right? I could actually, if it's a simple type, I could say, if it's just one thing, if I wanted a specific type of data back, I could say, give me a map, for example, a map.class. What I want is actually the collection of resource objects from the Spring HotOS API. So I happen to want that. So I'm going to go ahead and bring in Spring Boot Starter HotOS, and that'll give me the envelope object that we talked about earlier, the resource. Okay, there it is. And you can see that once I've done that, I now have in my code here. Let's see. Where's the resource? Oh, yeah. Why does that? Resources. There we go. So you can see here when I add that to the class path that it's referencing the resources object from Spring HotOS. Remember what we talked about earlier. A resources object is a collection of resource instances. The payload of the resource instances is of type reservation. Notice that in my code here, this does not compile. The reason this doesn't compile is because I don't have the jar containing that type on the class path. I could, of course, take the jar from the service and add it to the class path, but this would be a very bad idea. This would couple my client to the service implementation. I would lose one of the big benefits of having microservices. I would be coupled to the release cycle of the service on the server side. So instead of coupling myself, I'm going to create a client-side representation here, simple, called reservation. And if that service is written using something, and again, it hurts me to even admit this. It just hurts. It's possible that that service was written using something besides Spring and Java. So again, we must accept the fact that our client may be talking to a service written in a different technology stack. That's why it's also very useful to keep a client-side binding. So we're going to say private string reservation -name, and we're going to create a getter like this, and then we're going to route the request, and we're going to tell the REST template that we want the JSON that comes back from the server to be turned into a collection of resources basically, whose payload is of type reservation. So there we are. Now, I can map the response data. I can say response entity.get body.get content.stream.map, and I'm going to map for each reservation. I'm going to map from a reservation to the reservation name. I'll collect the results here and a list of names. So what I'm going to have here is just the names, not the hypermedia links, not all that other information, just the names from the REST service. If we revisit our edge service here, now on port 9999/reservations/names, we should see the names reflected in the output here, just the simple names, nothing else. So our edge service is providing a view of the data for the client. Again, is this a very useful edge service? Probably not. But again, I'm trying to keep things simple. What happens in this case if there are 0 instances of my downstream service, the reservation service? We know that if there are 1 or more instances of that service, then things will be okay. Ribbon will do round-robin load balancing automatically for us. This makes it so that if we have 1 or more instances, everything will work just fine. Even if we call a service and that doesn't work, the load balancer will call the next one, right? However, what about 0, right? And if there are 0 instances, it's going to attempt to make the call. We can relax because we know that there is a useful default for the timeout already specified. However, it'll still throw an exception. It'll still cause an error, and that error will be sent back to the client. It's a very bad experience if you have a Java stack trace in your iPhone application, right? You want to protect your iPhone clients from seeing that something is wrong. You want to be more aggressive, more defensive when you stand up these services. It's critical that your services are able to gracefully degrade. This is very, very common. My friend Chris Richardson, he talks about this all the time. He suggests, wouldn't it be ridiculous if you cut your finger and then you blue screened, right? You, as a human being, are able to gracefully degrade. You can cut your finger and still work. Your system should do the same thing. Netflix does this. All operationally mature organizations embrace failure. In a sufficiently distributed system, it is important to forget about high availability. High availability goes out the window. It is a dream. You will never have 5 nines of availability for a distributed system. Something will always break. Netflix and Google, for example, both understand this. If there are people that work for Google, that go to Google in their Google bus, and when they get to the Google offices, they check their Google Mail on their Google phones, and then they get their Google breakfast and talk to their Google colleagues. Sometimes they'll take their Google bikes around the Google campus and then visit the Google data center where they'll find lots and lots of custom-made Google servers. These Google servers will have Google crashed, and it's not a problem. They don't stress about these Google failures because they know that something is going to break every day. They have 2 million or more servers deployed in all of their data centers worldwide. 2 million very strong computers. Statistically, something will break every day. Many devices will break every day. They don't care. They have built their software to embrace failure. Same thing for Netflix. Netflix has a very big distributed system. They have more than 600 microservices and probably just as many different clients. They embrace failure. In fact, they invite failure on purpose. They have a suite of software called the Simian Army. The Simian Army is a set of components that are designed to create havoc, trouble, pain, randomness. They release this software in production, and they have components that do silly things like killing a disk or RMRFing, a file system mount, or killing a database partition, or kill -9ing, important processes on servers. They even have a component called Simian Kong, and Kong is the big one. Kong kills a whole availability zone. So if you have a data center replication strategy for Amazon West and Amazon East, Kong will kill everything that's running in a certain availability zone, all of Amazon East for you. Imagine your whole data center going down. Are you ready for that? They know that they're ready for it because they do it on purpose when people are at the office. They would much rather find out if something is going to fail poorly during office hours when people are available to respond to failures. They do this so that they know for sure that their software is resilient to failure. So we need to do the same thing. We need to be a little bit more resilient here. We can support making our reads more resilient by adding a circuit breaker around this service-to-service call. So I'm going to go to my code up here, and I'll say enable circuit breaker, and I'll scroll down, and I'm going to wrap the method that makes the call in a circuit. I'm going to say add Hystrix command, and I'm going to say that whenever somebody calls this method, if the method should throw an exception, then I want a fallback method to be shown, to be used, right? So I'm going to just, in my fallback method, I'll just return an empty list of strings, nothing in it, right? Netflix does this a lot. For example, you'll see sometimes that the search engine inside of Netflix will be down. They'll say, okay, well, search is not working, but here are some recommendations from across the web. It's not exactly what you're looking for, but it's better than a failure. It's better than complete ugly stack trace in the client. So let's see if that worked. If we go to the edge service, make some requests, things are fine, great. Now what happens if we go downstream to the reservation service and then kill the reservation service? Refresh the edge service, it stutters, it hesitates for a minute. But now if I make the request, you can see we get the empty array list. The first several requests to the edge service take a long time. It's going to try before the timeout kicks in. It's going to try and make the requests, but eventually this request will take no time at all, and that's because the circuit breaker that we have used is stateful. It is looking at all the requests that go in through that circuit, and it tries to route them to the broken downed the service that has fallen down. It sees that a certain number have failed, and so it'll no longer even try. It'll just move all traffic to the fallback method directly. That means that we have given our downstream service, we have given the reservation service a time to come back online. It is our job as developers to build software that is aware and works with failure. If you have a cloud platform like Cloud Foundry, you can rely on Cloud Foundry. You can trust Cloud Foundry to pick up the service if it falls down. If you tell Cloud Foundry that we need 100 instances of this service running at all times, then if the service falls down, the heartbeat will detect the failure, and immediately Cloud Foundry will restart the service. You have to give that service time to come back online, though. Cloud Foundry will wear the pager, right? You can sleep at night not worrying about the service if it falls down, but you do have to build the software to do the right thing if something should fall down. Now, that circuit breaker will also heal correctly. So if you re-register the service and you give some if you let the default timeout elapse, then eventually subsequent requests will go directly to the actual service again. So this is good. This works for reading. But what about writing? How do I write data to the edge service if my other service is down? I can't use a circuit breaker. After all, what does it mean to fall back if I can't actually write to the database, right? In this scenario, I want to gracefully degrade. I want to make sure that the data is at least collected somewhere. This is called eventual consistency. At this point, some architects, very lazy architects, intellectually lazy architects, reach for something called distributed transactions. I urge you to, if you have this instinct, if you have this feeling, if you have this need, to go home, have some alcohol, drink some wine, maybe some scotch, hug your children, hug your wife, do whatever you have to do to convince yourself that using distributed transactions is actually the worst idea ever of all of the ideas. And instead prefer eventual consistency. Even banks use eventual consistency and do not use distributed transactions because it slows the system down too much. Now, what we're going to do is we're going to use something called Spring Cloud Stream. I'm going to add it to both of my services, my client, my edge service, and my reservation service. So I'm going to bring in Spring Cloud Starter Stream RabbitMQ, and also I'll bring in my distributed tracing support because we're going to need that later. Now, Spring Cloud Stream is an abstraction. It sits on top of Spring integration. Spring integration is a component model, a framework for building distributed systems based on messaging. The idea is that I can use it to describe complex event-based integration flows. It does for event-based and messaging-based architectures what Spring MVC does for HTTP-based architectures. It's a component model that abstracts away a lot of the boilerplate. You can use Spring integration to compose complex streams of processes. For example, I can say that whenever a message comes in from Kafka or RabbitMQ or Redis, that an inbound adapter is supposed to take the data and send it on a channel. There, I can add another component on the end of the channel, which is a pipe, basically. I can add a component to the end of the channel to respond to the message, like a message listener container. This is very, very powerful, and it means it's easy to compose very complex flows. But Spring Cloud Stream lets us go one level higher. Spring Cloud Stream has at its heart the idea of this message channel from the Spring framework, which is what Spring integration uses. A Spring message channel is like a java.util.queue. You can push and pop messages. I want to be able to describe services using message channels as my input and output. I don't want to worry too much about where these services live and how to get to them. In the same way that Eureka lets me talk about different downstream services that are based on REST and HTTP, Spring Cloud Stream lets me work with downstream services based on messaging. So let's go ahead and see this in action. In order to do this, I'm going to, first of all, make my application a module. I'm going to define a binding here. I'll say enable binding. And the input to the enable binding annotation is a class literal for a declarative interface. And we'll look at what this does behind the scenes in a minute here. But for now, what you should know is that in this interface, you can describe channels. And Spring Cloud Stream will automatically create those actual channels for you and connect them to the downstream services. So here I'm going to define a reservation client interface and put this as the type here in enable binding. The name of the method is what's used to qualify the channel name in the configuration. And we can signal that this channel will send messages out by annotating it with @output. We can do the reverse on the other side by using @input. So let's go ahead and see this in action. Let's go ahead and create a new endpoint here on the edge service called public void write. And we'll take as part of our definition here a request body whose payload is of type reservation. And we'll accept HTTP post methods to this endpoint so that whenever somebody sends JSON with the reservation JSON in the body, it'll get written to this endpoint. And here we can write the change, we can write the message using Spring Cloud Stream and the new channel that we've been given, like so. So we'll say reservation client, and actually I can make this more appropriate. I can say reservation client channels. There we are. And here I'll say this dot reservation client dot output. That's the message channel. And I'm going to send a message. I'll say output dot send message builder dot with payload. Oops. Wrong one. I don't want this one. I want the other one. Make sure you use this message builder from Spring Integration or from Spring Framework Core. So let's see, try that again. Message, string message equals message builder dot with payload. There we go. Dot equals reservation dot get reservation name dot build. Okay. So there's my message. It's got headers and a custom payload, which in this case is just the name that we want to write to the database. I'm going to send the message out like this. And on the other side, the downstream service, the reservation service, will do the same thing in reverse. We'll take the message in and then write the data to the actual database. So here we're going to say @enable binding. And again, I could define a custom interface, but to be honest with you, sending a message out on a channel called output and sending a message in on a channel called input is such a common thing that Spring Cloud Stream provides default interface definitions that we can use instead as a shortcut. So I'm going to actually just use that default one that comes with Spring Cloud Stream. If I want to go back to the reservation client, I could have used, instead of my custom one, I could have just used something called source.class, and the result would have been the same. So here's the reverse. Here's the input. A source, of course, is like a source. It's a producer of messages, and a sync receives the messages, right? So we're going to say enable binding sync, and I want to use Spring integration to write a very simple messaging component that will respond to all messages that come in on this channel called sync. So I'll say @message endpoint class reservation processor, and I'm going to say public void accept new reservations, and the payload I'm going to just inject. I'll just tell Spring to give me the payload. I don't care about the headers for now, so I'll just describe the payload directly, and I'll use the service activator annotation to tell Spring integration that whenever a message comes in on the input channel, that it's going to call this method, right? And once this method is called, I'll write data using my repository to the underlying database. I'll say reservation repository, like that. And I'll say this reservation repository save equals new reservation, passing in the payload there, right? So there we go. Now we have a messaging component on the service that should respond to any requests that come in on the input channel. And then on the client, we should be able to write the changes. Now let's go look at the configuration while this is coming to life to understand what it's doing. In our config server here, we have on the reservation client.properties the definition Spring Cloud Stream bindings dot asterisk, asterisk means anything, dot destination equals whatever, anything. Okay? Output is the name of the channel in our Java code. Reservations is the name of the actual memory in the message bus, in the broker somewhere. If we're using Spring Cloud Starter Kafka, then this will be a destination in Kafka. We're using RabbitMQ, so this will be an exchange and a queue in RabbitMQ. If we're using JMS or Chronicle or Redis, then this becomes a destination, etc., etc., etc. It's abstract. We don't have to worry too much about what it means for that to be on the broker. Spring Cloud Stream will take care of that. By default, Spring Cloud Stream has publish, subscribe style semantics. It sends a message, and everybody that's connected on the other side will receive the message. In our case, I want to have an exclusive consumer, one-to-one, point-to-point. So if you look at the configuration here for the reservation service, which is going to receive the message, you can see it says Spring Cloud Stream bindings.input.destination equals reservations. So again, they've agreed upon where to meet in memory, in the broker, in Kafka, in RabbitMQ. They agree that messages will come in and go out of reservations. But we've also specified a group. Everything in the same group is exclusive. So if there are 10 nodes connected to the group called reservations, then only one instance, one node in that group will receive the message. I also want the message to be redelivered if this downstream service is not available. So I've specified that it should be input.durable subscription equals true. This means that even if the downstream service falls down, I will still eventually get the messages. I've used eventual consistency to guarantee that the write will eventually be transacted. It'll be processed correctly. So let's go ahead and see this in action. I've started up the reservation service. Great. Let's go ahead and start the reservation client. It's spinning up. I'm drinking water, in case you're wondering. Okay, now, I'm going to use an HTTP REST client called Postman. It's free and easy to use, and and so on. So there's that. And I'm going to send an HTTP post to localhost 9999/reservations. The body will just be, what? Go away. The body will just be some name. So what's another name?
John.
I think I already have John.
Dieter.
Again, okay. Dieter. Okay, there we go. With an exclamation mark. So if I hit send, and I go to my edge service here, oops. If I go to names, there's the new record that we've just written. So it's a messaging based flow I've written from the REST client to the edge service. The edge service added a message via RabbitMQ. RabbitMQ delivered it to the downstream reservation service. Now, let's see what happens if I kill the downstream reservation service. I'm going to go down here, okay, and I'll kill it. Poor service. And I'm going to send a few messages. I'll send a new, Dieter, encore une fois, and I'll send that a few times, okay? 1, 2, 3. Now, let's start the reservation service again. Now, obviously, if I go to the edge service here and do a refresh, it'll give me the empty array list because the downstream service is not there. We'll restart the reservation service, give it some time to come back to life, and we'll see on the console, remember that we print out all of the names that are in the database here. We'll see on the console here that as it starts up, it should see 3 new records, right? There it is. There's the output. 3 new records. Those were actually loaded before of the rest of them. Remember, we're using an in-memory database, so I'm recreating a static list of 8 records every single time, but these 3 records were in queue, and they were delivered as soon as the application started up. So they were delivered even before we wrote the in-memory database records. And if we go back to the edge service here, it's not quite ready. It still hasn't been, it still doesn't know that the downstream service is available. So if we wait a little bit, we'll see that record available there, but we need to give it time. So anyway, in the meantime, while that's coming up, let's talk about visibility, because a cloud native application is not just one that is resilient to failure. A cloud native application is one that is visible and operationalizable. And as I said before, things like the Spring Boot Actuator framework make it very easy to expose interesting information about the application. But from a systems perspective, it can be helpful to have more. For example, I have one circuit. If I have more than a few circuits, certainly, even for one circuit, but especially for more than a few, I want to be able to see the flow of traffic through that circuit. I want to be able to see whether things are healthy or not, right? And so to support this use case, I'm going to build a Hystrix dashboard so I can visualize how data moves through the system. So Hystrix dashboard, config client, generate. And I'll open this up. Now I think, by the way, that the edge service should work. Let me try that quickly. There it is. So you can see when I give it a few seconds to respond, to refresh itself. I hit refresh again for the names endpoint, and there are the 3 records plus the static 8 in the REST endpoint from the edge service. Anyway, if we go to the Hystrix dashboard application, @enable Hystrix dashboard, and I'm going to bring in the Eureka support. I forgot that. Spring, Cloud, Starter, Eureka. Okay. And now I'm going to tell this to talk to the config server like before. Localhost 8888, and I'll say that the application's name is Spring application name equals Hystrix dashboard. Okay, and I'm going to rename this file to bootstrap.properties. There we go, and I'll restart. Having done all that hard work, it's going to start up, and it's going to need you to provide a server sent event stream, a heartbeat stream that every circuit, like the Hystrix circuit breaker, provides in the system. you can get to that stream by going to histrix.stream on the node that contains the circuit breaker. This histrix.stream is never ending. Do not, whatever you do not curl this endpoint. Now you can take that stream to the dashboard, which is on port 8010 here, /histrix.html, and you can paste the stream URL there into the dashboard. There it is, right there. And now if we go to the left, to the end service here, localhost 9999 /reservations/names. You can see that as I make requests on the left, the requests on the right go upward. They're immediately visible. And you can see that it's very sensitive to traffic flow. Right now, everything is great. It's very happy. As I make requests, traffic is flowing smoothly from the client to the service. The circuit is closed. But of course, if I kill the downstream service, the circuit should open after a time. Let's go ahead and see what happens. Oops, did I just get a message? Oh, I got a message from somebody else. Sorry about that. Let's go ahead and kill the downstream service here. We'll say reservation service. I'm going to kill it again. And by the way, notice that the average here on the right is 0 again. It's a moving average. So if I don't make traffic, then there are no requests. I see 0. Now the downstream service is dead. So when I make a request on the left, it's going to stop and then try and give me a request. Right now it's failing. I'm getting the circuit breaker fallback method. 100% of the requests are open right now. So this is useful. And of course I can see that the circuit is still closed, which means that it's trying to call the downstream service, but it's not succeeding. That's why it's taking so long each time I make a request. If I make enough requests on the edge service, however, that circuit will eventually open. See, now it's super fast. The circuit is open and no traffic is going to the downstream service at all. It's going directly and immediately to the fallback. This gives me the ability to, in real time, see the state of the system. This is great for places where you have circuit breakers, which help you guard against potentially risky or dangerous service-to-service calls. If you have more than a few services in a distributed system, however, it's also very useful to be able to understand the passage of messages through the system, to understand that when you originate a request from a client, which nodes that request has passed through. This is called distributed tracing, and in theory, this is very simple. All you have to do is add a unique correlation ID to every request that comes into the system at every place, through the HTTP server, through the REST template, through the micro proxy, through Feign-based interface clients, which we didn't talk about here, through the messaging code if you're using Kafka or Spring integration, RabbitMQ, etc. Through all of these different places, you have to simply correlate the request. And you have to propagate, you have to push the same UUID across different request boundaries. So if I make a request from my HTML5 client, it hits the edge service, the micro proxy, then that goes to a messaging or to another REST API, which may call another messaging-based service. And at each point, I have to take the single UUID, the correlation ID, and keep it as a header or something in each request. So in theory, that's very simple. In practice, this turns out that it's a very, very large amount of boring, painful work that will not help you as you look to become a better competitor in the market. So instead, Spring Cloud Sleuth does this automatically for you. Spring Cloud Sleuth clues, who investigates crime scenes and so on. So Spring Cloud Sleuth is our abstraction. It provides the idea, it provides this concept called a trace. A trace is a logical construct that refers to the traffic from the client all the way to the end of the journey of the request. Each hop, each request, if you have a large trace and that trace has 5 different services that it calls, then each one of those services is called a span. So each jump, if you have 5 jumps, there's going to be 5 spans. One trace though, right? So Spring Cloud Sleuth automatically collects all this information and makes it available for you. In fact, it even logs that information for you on the console. You can see here that in the console, in orange, it's showing me the service ID, the trace ID, and the span ID. And so if you're using a centralized log aggregator, something like Elasticsearch and Logstash and Kibana, or if you're using something like Cloud Foundry has something called the Logregator. The Logregator takes the standard out from all of your different running applications and multiplexes them into a single stream of logs. And then you can forward that log to things like Splunk or Papertrail or whatever you want to then do similar searches. Already, this gives you some information. It gives you some ability to understand how messages have passed through the system. However, we can do better. As I've said before, operational data is not about collection, it's about comprehension. What we want is to understand how this data is moving through the system and to understand how long it's taking for each request and so on. So to support this use case, we're going to use Zipkin. You will have seen me already earlier adding Spring Cloud Starter Zipkin to the class path. Spring Cloud Starter Zipkin brings in, as a transitive dependency, it brings in Spring Cloud Starter Sleuth. So we're going to use Zipkin. I've got Zipkin running on a separate server here in my Docker images, but you can also deploy it to Cloud Foundry. It's just there's also checkboxes. If you go to start.spring.io, you can even get some of that here, this way. You can go to Zipkin, for example, Zipkin stream, right? In our case, I've already got it running, and I'm now going to open that up. I'll go to 192.168.99.99.100.80.80, and you'll see you've got a very simple Zipkin web UI running. And in the dialog here, I've got the service that I want to talk to and the endpoints that were requested. So I can say, show me all of the traces for the reservation client. You can see here that a lot of my requests that I sent here before are one-legged, because the circuit was down. The circuit was open, the downstream service was down. So let's go ahead and look for the reservation service. Here's a request I made 6 minutes ago. If I open this up, you can see that it shows me that the request came in from HTTP reservation names. The total request took 26 milliseconds. If I click on each level in the waterfall graph, I can see the timings, I can see what are called tags, and these tags show you metadata about how the information is flowed from one system to another. You can add custom tags like order ID or customer ID or whatever you want here as well. Here I can see that the client has sent the request, the server got the request, and so on. You can see the logs, basically, of the data as it flows through the system. This is very, very powerful. You can now make reasoned, informed decisions about how data is moving through the system and where, if anywhere, there are gaps, right? So we've now, we've used the defaults. I've got a sampler in all of my Spring Cloud Sleuth configuration saying that I want every request to be sampled. You should not do this. You should at most sample about 10% of your requests. This data is not meant to be retained forever. It is not meant to be warehoused. Instead, consider this online telemetry data. Most organizations don't keep this for more than a few days, at most a week. And you should not trace every request. Even the data you should keep should be just a small percentage of the requests that have gone through the system. If you have a problem, believe me, you will see that problem very quickly, even with just 10% of your requests being sampled. Twitter, for example, I think they trace something like 1 out of every 6 million requests. 6 million requests. That's a lot of requests, and they will see the problems very quickly. So again, this is not to be used for archival purposes. This is to be used for what happened today. Was there an error today? Is my server okay in the last hour, etc. So, with that, I feel like we're kind of at a good stopping point. I wish we had more time. I really do. That way we could actually cover some stuff. Unfortunately we didn't get to cover almost anything today, but that's okay. Maybe next time. Maybe next time we'll be able to go the distance. You can see here there's a lot of other stuff, however. You can see in start.spring.io that we have support, for example, for something called data flow. Spring Cloud Data Flow provides a central server to manage the flow of data, to orchestrate the flow of data between services. You saw earlier that I used Spring Cloud Stream to pass messages in and then pass messages out. If you think about it, it's not hard to compare Spring Cloud Stream and the input and output channels to standard in and standard out. If you think about how we work with standard in and standard out using a bash shell script, to compose streams of useful functionality, Spring Cloud Data Flow lets us do the same thing for messaging-based microservices. You can compose complex flows of data using a bash-like syntax. We also can use Spring Cloud Cluster to manage things like leadership election and master worker and sync and distributed locks and so on in a distributed system. We can also use things like Spring Cloud Security to handle single sign-on. So for example, suppose I want to secure my edge service and accept OAuth tokens and then propagate that OAuth token to all of my microservices for authentication. It's very easy to do this using Spring Cloud Security and OAuth, right? We even provide an OAuth identity provider that you can use, or you can use anybody else's OAuth identity provider, of course. So there's a lot of other stuff that we could have talked about here, above and beyond the very basics that we've talked about thus far. I appreciate your having spent the time with me today. J'espère que ça a été très utile. Merci d'être venu. Merci d'avoir fait l'attention. Si vous en avez, je peux répondre à vos questions.
All right. Thank you very much, Josh Long.
Plaisir.
Very interesting presentation. I love it very much. There are some people here in the room. They're inside of the room. I'm outside recording this. So if they want to pose any questions, I invite them to come over. They will receive this message from me in about a minute. But I have a question for you first.
Yes.
I love the start.spring.io, all the options that you have to really start very quickly with an application.
Mm-hmm.
And I was thinking, how big is this going to get? How many things are you going to keep adding? And will it stay manageable for you? For people?
Yeah, because a lot of these integrations on start.spring.io are third party, right?
Yeah.
And that's fine. By the way, I should have spent a few minutes to explain to people how this works. When Spring Boot starts up, it looks in the class path for a text file called spring.factories. There, it finds this text file in the meta-inf directory of certain jars. You can do the same thing, by the way. In that jar, you can see a list of Java configuration class names. For example, Rabbit Auto Configuration. This is just a Java configuration class with bean definitions at configuration. And you can see here, AMQP admin, Rabbit template, etc. This Java auto configuration is guarded thanks to conditionals. So here it says, I only want to use RabbitMQ auto configuration if this type, the Rabbit template and channel, are on the class path. In my case, right now, because I'm using Spring Cloud Starter Stream RabbitMQ, these libraries are on the class path. But if they are not, then these definitions will be they will not be evaluated. So here we're getting default beans, we're getting default behavior just by adding libraries to the class path. We also have other conditions. For example, here it says, if somebody has already defined a bean of type Rabbit template, then do not bother with this definition here. So you can provide your own Rabbit template, and that'll be used instead. This is called auto configuration, and it is the way that Spring Boot and Spring Cloud provide all of these useful defaults. You can do the same thing. You can create your own auto configuration for your own organization, and you can put it on the class path of your Spring Boot and Spring Cloud-based services and get common, sensible defaults. You can customize the health indicator. You can connect security. You can do whatever you want. And now, whenever somebody in your organization wants to start a new project, instead of that terrible wiki page with 5,000 steps, they can just add the auto configuration and get defaults. Indeed, even start.spring.io, the initializer, is open source. So go to github.com, spring-projects spring-io/initializer, and you can take the code and then customize it, add your own starter dependencies. You can have your own start.whatever.io, right? Have your own server that does the same thing. So now in your organization, all services can be the same and work the same and benefit from consistency.
All right, I just put myself on mute for a while. I have another question.
Yes, sir.
Yeah, one question from the YouTube channel. So whether Spring AWS will support AWS Lambda?
Spring also
AWS, yeah, Spring AWS. Will it support AWS Lambda?
Well, so Spring again. I'm not sure what's required for us to. Does AWS Lambda already support Java?
Yeah, as far as I know, yes.
Then yeah, it should be just fine, right? So, for example, we have something called Spring Cloud Task. Spring Cloud Task is an abstraction around the idea of running a short-lived task, and you can certainly use that for Lambda, or you can use Dataflow, right? Dataflow itself has the ability to run tasks across the cluster, and those could be Lambda-based deployed services. We have also with Cloud Foundry the idea of a task. So again, that could be a natural way to get that same behavior of just a request comes in, I want to spin up some behavior, and then kill the behavior, kill the process.
All right, another question then.
All right, I have a question. I've seen new features from Spring Boot milestones, like the one where there's more descriptive error messages, which sounds very interesting. Are there also other features coming up for Spring Boot and maybe as well Spring Cloud that we don't know about yet?
For Spring Boot, let me think. So you saw Andy Wilkinson's really descriptive feature messages. What else is coming in Spring Boot 1.4 that I may not remember? I know there's better integrations with other technologies like Couchbase, for example, and Neo4j4 are both inside of the Spring Boot starters for that. I don't remember. Oh, and testing, right? Phil Webb, the co-founder, is working on really making the testing story really great for Spring Boot apps as well. So there's a lot of stuff coming. You'll see, you can check out the GitHub issues. I'm afraid I don't have an exhaustive list on hand. For Spring Cloud, yes, there's a lot of stuff coming, right? So a lot of what I've shown you today is actually milestones or release candidates for code that will be in Spring Cloud Brixton, which is due at the end of this quarter. It'll be available soon.
All right, very cool.
Yeah, so distributed tracing, Consul and Zookeeper support, Spring Cloud Security, Spring Cloud Stream, the Dataflow stuff, that's all based on the new version of Spring Cloud.
Yeah, at the moment I'm working on trying to fit Spring Social and Spring Session together with a Redis backend instead of the JDBC backend.
Cool.
With the new features from the 1.7 from Spring Social, I guess, or Spring Boot.
You should open source that code if you get working.
Yes, that's the idea. So I'm trying to work on that. So I'll send you some questions for hints and tips, tricks and stuff like that when I get to it.
Okay, wonderful. Thank you.
So I think there's no more questions for now. So I would like to thank you very much for doing this. I'm sorry. I'm thanking you very much for doing this under this given circumstances. You see, we're not letting the bad people win, so we're still doing this.
Exactly.
That's very good.
And
it's
my pleasure.
Yeah, thank you. And I would like to thank everyone at EMC there and at Pivotal in Paris for helping out with that.
I'm sure they say thank you very much too.
Yeah, you're welcome. And it's too bad you'll have to pass on the good beer that we're drinking here, the good Belgian beers. The Westmalle and stuff like that. We had them all set up right for you, but that'll come in the future.
I hope so, my friend. I'm really sorry about, quel cauchemar,
Yeah, it was not in your hands, so no worries.
Okay.
So,
Well, thank you very much for your time, everybody.
Yeah, I think I'll end the stream here. Thank you very much, and see you next time, man.
Cheers.
Bye.